We are studying ways to improve indoor air quality in an economical and eco-friendly way using lampshade systems.
Hello, I'm Sophie Robner from the American Chemical Society. Welcome to this media briefing from ACS Fall 2023. Indoor air pollution may have met its match. Today, scientists will report that they have designed catalyst-coated lampshades that transform indoor air pollutants into harmless compounds. The lampshades work with halogen and incandescent light bulbs, and the team is extending the technology so it will also be compatible with LEDs. To tell us more about this, we're joined today by Hyung-Il Kim and Min Hyung Lee from Yonsei University. Thank you for joining us.
We appreciate the opportunity to be here.
Thanks for having us.
Where did you get the idea to do this project?
The inspiration for this project emerged from our existing research focus. Our group has been working to develop environmentally friendly air purification systems that utilize both photocatalysis and summer catalysis. And actually, the application of these catalytic processes in indoor environment present considerable challenges because photocatalysis requires strong UV light source, which is detrimental to human health. And also, summer catalysis typically requires additional heat energy sources, which is expensive. However, we found that commonly used halogen or incandescent bulbs prevalent in cafes and home interior in your house emit a substantial amount of summer energy ranging from 100 to 160 Celsius degree, which is sufficient to activate some of the summer catalysts. So we decided to repurpose this waste heat from indoor lamps as a sustainable energy source for summer catalytic air purification systems.
Can you briefly describe your research?
We are concentrating our effort on advancing eco-friendly and sustainable catalytic processes that can effectively remove gaseous indoor pollutants such as formaldehyde and acetaldehyde and sulfur-containing substances that cause odor.
What did you find out, and what are the implications of these findings?
As previously mentioned, we have pioneered the first lampshade-based air purification system that harnesses indoor waste heat. In this context, we have strived to enhance the efficiency of these lampshade systems. Accordingly, we have systematically investigated some catalytic activity of various catalysts, including CO2 and its hybrid. Our initial study was to focus on platinum CO2, a remarkable summer catalyst when it combined with indoor lamps. As we progressed, our attention shifted toward developing a low-cost catalyst without precious metals like platinums. And it found that specific non-precious metal co-catalysts, for instance, copper and ions, can effectively improve the catalytic efficiency of discharge-based systems. In addition, we have conducted a systematic investigation on various parameters such as humidity and temperatures and the light intensities, etc., which are greatly influencing on the catalytic activity of these systems.
And how does your method compare with other air purifiers that are on the market or being developed?
Conventional air purification systems generally contain a solvent, such as activated carbon, to capture gaseous air pollutant after they first remove particulate matters through the filtration processes. However, this is just the separation processes, wherein the gaseous pollutant absorbed onto the activated carbons, not completely removed. And recently released air purification systems started to incorporate full clarity processes. However, most of them fundamentally rely on a strong UV light source, which is dangerous and expensive, like I mentioned before. On the other hand, we focus on the waste heat energy naturally generated from the lamp side and design the sustainable air purification system that utilize this waste heat energy for the complete removal of various gaseous air pollutants. Actually, the final product only the CO2 and the water molecules. Establishing this system is remarkably simple and convenient. It only requires coating of catalyst paste onto the existing lamp shade in your home.
What VOCs are typically present in the home?
So in general, various VOC exist depending on the indoor environment, such as home, office, or factory. Typically, there are three substances in the house. First, formaldehyde that causes sick house syndrome. Second, acetaldehyde generated from furniture or paint. And last, BTEX generated during cooking. These are representative things in the house. And actually, our lampshade system can treat all of these VOC, but only the aldehyde substance was covered in this study.
What amount of VOCs are typically present, and how much could your lampshade treat?
VOC that exist indoors are very small concentrations, actually almost under 1 ppm, but if continuously inhaled, the concentration will be greatly bigger inside the human body. And even a small amount of VOC can cause many bad effects, such as allergies, respiratory problems, and headaches. Our lampshade system was tested at a higher concentration of 10 ppm and successfully removed it completely.
Could your product also destroy bacteria and other microorganisms like other products claim?
Actually, we have not tested an experiment to sterilize bacteria or microorganisms yet, but we expect that our lampshade system will be effective because most bacteria die at a temperature of 100 degrees Celsius, which is lower than our system. But if that doesn't work, we can change our coating materials, such as copper-based catalysts, which have stronger disinfection power, then it will be solved.
And finally, what will you do next?
In our previous studies, we only focused on thermal energy of traditional indoor lamps. However, the recent trend of the light bulb is changing to LED that do not generate high temperatures anymore. So we have to follow the trend, and we will develop some materials that can be used for LED lampshade. In the case of LED, longer wavelength light energy accounts for more than half of the light energy, and it is not enough to activate the photocatalysis. Therefore, we are developing a photothermal conversion catalyst that can convert weak light energy to stronger thermal energy. And confusing with visible photocatalyst, this would be a photothermal composite that can effectively utilize LED as both of light energy and heat energy. Finally, we believe that this technology will be the easiest way to get clean air in people's home and protect indoor air quality.
Thank you both for sharing your research with us.
Thank you for giving us the opportunity to introduce our research here.
Be sure to check out our other media briefings for ACS Fall 2023, which will be posted throughout the meeting at www.acs.org/ACS Fall 2023 briefings.